All right, so today we're going to be doing an example where we calculate the term of debt in an amortization problem. So it says here the municipal government decides to make a public investment costing $8 million. An economic study indicates that $150,000 per semester can be obtained from contributions. The government's goal is to issue bonds worth $8 million to finance the investment and establish a sinking fund generally generating an interest of 8% per year, compounded semi annually. How much time is required to collect the total amount of bond issuance? Okay, so basically, what we have to do is we have to calculate the time with the future value formula of an overdue annuity. And this time, we're going to be using logarithms in order to solve for the amount of time that must accrue here, right? We need to know how much time is required to actually collect the total of the bond issuance. So let's start with the basics here. So, what is our future value? Well, the future value in this case is $8 million. The annuity amount, right, the amount that is going to be paid each semester, is going to be $150,000. And then the interest rate is 8% annually. And so semi annually, because they did say this is compounded semi annually, we'd have to divide that by 2 to get 4%. So therefore, the interest rate is going to be 4% per 6 months, basically. And we're going to be calculating n from the future value equation for an overdue annuity. So just to remind everyone what that would look like, that's going to be future value is equal to the payment times 1 plus I to the power of n minus 1 over I. So that means in this case that $8 million is equal to $150,000 times 1 plus I, so that's going to be 1.04 to the power of n minus 1 over I, which is 0.04. Okay, so then we need to solve for n, and the first thing I'm going to do is I'm going to divide $8 million by $150,000. And that's going to give me 53 and a third dollars, so 53.3 repeating, is equal to 1.04 to the power of n minus 1 all over 0.04. So then I'm going to multiply both sides by 0.04, and then I'm going to add 1 to both sides. So then I get that 1.04 to the power of n is equal to 3.13 repeating. All right, so next we're going to use logarithms to figure this out. I'm going to take the logarithm of both sides. So log of 1.04 to the power of n is equal to log of 3.13 repeating. Okay, next I'm going to remember the log rule that whenever we have this n as the exponent, we can put it at the front. So therefore, n times log of 1.04 is equal to log of 3.13 repeating. And then if I divide both sides by log of 1.04, I get that n is equal to log of 3.13 repeating over log of 1.04. And let's plug that in the calculator. So log 3.13 repeating is equal to, and then divide by log of 1.04 is equal to. All right, and I'm getting 29.12 approximately. Okay, so basically slightly over 29 years. So at just over the 29-year mark is going to be the time that it would take here. However, the thing is, this was actually in semesters, right? This was calculated semi-annually. So actually, this is just saying a little over 29 terms. So we have to divide by 2 to get the number of years. So that's going to be just over 14 and a half years. So 29 and a little bit of extra terms is going to be approximately equal to 14 years at 14.5 years, and then a little bit extra, right? That extra 12% of into the next semester there, basically. So between 14.5 years and 15 years would be the N value there. All right, well, if there's any questions, please feel free to leave those in the comment section, and we'll see you for the next one.